Okay, so yesterday we talked about the definition of inverses, and there were two main definitions we talked about. The first one was on the graph. Okay, any inverse functions are going to be reflections over that line y equals x. Today we're going to do a graph of functions so that we can show that. And then we also talked about how you can switch the x and the y variables, and that's going to play a part into this next example that we're doing. So in example 2, it says use inverse operations to write the inverse of the given function. So when you're using inverse operations, you are going to have to show those steps. So for some of us, we're going to have to slow down a little bit and make sure that we have them because we do want to emphasize what operations are leading to that inverse. So inverse operations are as simple as, if you have something added, you're going to subtract it. Okay, if you have something divided, you're going to multiply, or vice versa. So you have to make sure that you show each step when you are finding the inverses. So some of us are just going to have to slow down a little bit there and make sure that you are showing those inverse operations. Okay, so we've broken this down into 3 steps. The first step is to switch the x and the y variables, and that is part of the definition of an inverse. If you look down at example A, you aren't going to see a y though. So remember, your f of x is your y. They're both your output variables. Okay, and then we're going to solve for y using the reverse order of operations. So everybody remembers PEMDAS, but nobody thinks of SADMET. That's how you solve, right? You got to either subtract or add over first, then you multiply or divide, then you look for what's inside your parentheses. So that's what we're going to use. And then the last thing is to write the equation in inverse notation. So we introduced that notation yesterday. That's where you have the F inverse. That notation is that -1 there. And so all of your final answers will be written with that when you're finding the inverse of f of x. Okay, now this year when you're first learning about inverses, we stick to linear functions. And so we're going to use the linear form, y equals mx plus b. And we're also going to be graphing, so this is the most helpful form to have when you are graphing. Okay, so that's what we're going to write them in. All right, so starting with A, you have f of x equals, that's the same thing as y equals 3x minus 8. So step 1 is to switch the x and the y. So we have x equals 3y minus 8. Okay, and then once you've done that, we are just going to solve using inverse operations. So you guys are really good at solving linear equations at this point. We just have to make sure we're writing out our steps. So this would be x plus 8. Divide both sides by 3. All of this is step 2. So when you're dividing by 3, you have to divide both of those by 3. We are going to simplify.
Teachers, please excuse the interruption. At this time, please release the boys freshmen and JV basketball players to make their welcome time. Thank you.
All right, and then we are going to make sure that we put that slope in front of the x. Okay, so if you have x plus 8 over 3, x over 3 is the same thing as 1/3 x, and then we're going to leave that as 8/3. And that is going to be your equation in inverse notation. All right, and then for 2, we're going to start the same way. So every single time, you can just start by doing x equals, and then you're replacing x with the y. Okay, now remember, whenever you have a fraction, there really is this understood grouping symbol here, right? These stay together. So the parentheses are what we deal with last, The first thing we're going to have to move over is that 3. So how do we do that? How are we going to move over this 3? We're going to multiply. So to show that, we're going to put parentheses around what we're multiplying. We'll have 3x equals, and those 3's divide out to make 1. Okay, and then I want you guys to solve that for y, and then write that in function notation. And if you finish that, feel free to go to part. Okay, and again, we're just making sure we show all the inverse operations that we're using. So first we add, then we're going to divide. Okay, and once you get there, it's fine if you just say, yep, this is my inverse, 3/4 x plus 5/4. Okay, that's your final. Say it again. Is it only inverse because we're doing the inverse? Oh, because it's because you have the switching of the x and the y, and then you're solving for that. Yeah. Oh. Okay, and then for C, there's 2 ways that you can go with this. So your first step is the same no matter what. You have x equals 3, y minus 7. And then I just want you to solve that however your feeling is correct. Okay, there's 2 correct paths. You have to choose your own adventure. All right, so how many of you distributed? Okay, so I thought most of you would distribute. Okay, so one way is to divide by the 3 at the start. Hi. Broken clay. Okay. And so this is going to be your 1/3 x equals y minus 7, and then you would just add 7 to both sides. So this is if you didn't distribute. Okay, and then if you did, then you get to x equals 3y minus 21. You'd add 21 to both sides. Okay, and again you get 1/3 x plus 7. And then of course you're going to write that in inverse notation. Okay, so it does not matter which path you took. You should end up with the same answer. All right, so now what we're going to do is we are going to be graphing those functions, and we're going to write and graph the inverse as well. Okay, so we're going to graph the given function, and then we're going to write and graph the inverse. Whenever you are graphing an inverse, you are also going to graph that line of reflection. Okay, and that line of reflection is just y equals x. So you're always going to graph that. Okay, so let's start by just finding the inverse for this. Switch your x and y, and then we're going to solve for y. So go ahead and do that. And then I just put the straight edges out today because we're going to be graphing linear functions. So I'm going to grab one and grab another weight in, and I'll go take that. Again, we're just showing those inverse operation steps. And here, if we're doing this without a calculator, instead of dividing by -1/2, it's a lot easier to just multiply by what? Yep, I would actually multiply by -2, the reciprocal. Okay, so when you do that, -1/2 times -2 is just 1. So that's how you end up with just your y value. And then you do have to make sure you distribute here. So that can be kind of tricky sometimes, people forgetting to distribute. And this is your inverse. So -2x minus 10. Okay, when you are graphing linear functions, there are a few ways to do this, okay? The simplest way, most of the time, is to start where? At your y-intercept. And then how do you find your other points? Once you're, yes, great. Okay, so start at your y-intercept, and 2, use your slope to find the other points. Use that rise over run. Okay? Yeah, that's how we're going to do it. Yep. And then the other method that we're going to use is we're also going to be making a table. So you can use the slope to find the points, or you can do the table. Okay, but we're going to be doing that without a calculator. So when you are graphing your function, okay, your f of x here, we are going to make an x and y table for that. We are also going to make one for the inverse. Yeah, well, technically for this one, like if it didn't tell you to, I would not make you know. But on your homework, your worksheet, it does say to make a table. So we're going to talk about what situations that's going to be useful in, because this one you wouldn't necessarily have to. So you have f of x equals -1/2 x minus 5. So where would we start when we're graphing that? Yeah, -5. So we're going to start at 1, 2, 3, 4, -5. Okay, and then your slope is 1/2, so that means you're going to go down 1 over 2. Down 1 over 2. And then you can go up 1 over 2, up 1 over 2. Okay, and of course, the more points you have, the more accurate your line is going to be. And we'll connect that with a straight edge. And then we're going to label this. So what we just graphed was the line f of x. Okay, so let's say what are some points on f of x we graphed. It's very common to put the intercept in the middle, 0, -5. And then I went down 1 and over 2. What's the next nice whole number point that I have? Yep, to -6, because I went down 1, so that's my -6, but then I went to the right 2. So when I do that again, where am I going to be on my x? So what's this point? 4, -7, because you're going over 2, down 1. Okay, so then let's do 5. That's our magical number. So if I go to the next one, the next whole number point is what? -4 will be on there, yes. But this is where? -2, -4. Yeah. And then the next one will be at -4. And my y value will be -3. Okay, now this line is also pretty simple to graph because you have a whole number as your intercept. So you start at -10. Usually we go down 2 over 1, but this is going to be up 2 over 1. And you're going to have to go, if you go up 2, you have to go to the left. Make sure that your line is going the direction that you want it to go. As in, if you have a negative slope, it should be going down from left to right. And if you have a positive slope, it should be going up from left to right. Okay, and then when we're filling out the table, the relationship between these is the x and y are just going to switch. So for the table, this is -4, -3. My point over here is -3, -4. -4, -2. Okay, so like I said, we had some really nice y-intercepts. What might be a more difficult y-intercept to graph? Yes, if you have a fraction, right, or a decimal. So if you are finding the inverse and you get a fraction, right, you get 1/3, you don't have to start at 1/3 and find those points. You can just flip your tables and then you can graph those points. Okay, and then what's the last thing we have to graph? Yep, which is the line of reflection. So the line of reflection should be on your graphs as well. That's y equals x, which means it starts at 0, 0, goes up 1 over 1. It also just goes through the center of your origin. Okay, this is y equals x. Okay, and if you graphed correctly, these two lines should meet right on that line. So if you graph this line of reflection and they are not meeting there, then something went wrong. And then you can see too, like this point is where they intersect, and that will all line up together. All right, so in the last one, this is a story problem application. You are going to have a story problem application on your homework, but they give you the equation and you just have to solve to find the inverse. So I'm going to help you come up with the equation for this one that we're doing, and then we'll solve it together. Okay, and then this one is missing a word. So this should say, one buys a CD online for 20% off the list price. And I said, I think we should change this to a record instead of the CD. Nobody listens to CDs, but vinyl's coming back, right? Some records, you do? I love that. Yeah, I have like a combo one. Okay, so he buys this online for 20% off, and he has to pay $2.50 in shipping costs. His total charge is $13.70. We have to do a couple things. One is we're going to find the list price of the CD, which just means the original price. Okay, what was the original price of the CD? And then write an equation to model the situation. So like I said, when you're doing this on your own, you will be given an equation and then you will have to solve that equation to model the situation. Okay, so first let's make sure we understand if something is 20% off, how much of the original price are you paying? 80%. So this is 80% of the original cost. We'll do the dollar sign symbol. Okay, so the way that we say that we represent that mathematically, we write the percent as a decimal, which is 0.8. We're going to call it 0.8p. P is going to stand for price. Okay, and we're also going to have the variable c that stands for the total cost. Okay, so the total cost that he is paying is 80% of the original price plus the $250 in shipping. All right, so when you are doing this on your own, you're going to be given an equation like this. And then the equation that models the situation is going to be your inverse equation. So what we're going to do is we're going to solve the equation for P because we're trying to find that list price there. Okay, so then we're just going to subtract 250 from both sides. So we have C minus 250 equals 0.8p. To get the p by itself, we're dividing by 0.8. Okay, and if you are not dealing with an f of x function, I'm perfectly fine if you leave your equation like this. You don't have to divide each one by 0.8, but you can. And when you're working with decimals like this, okay, it's okay if you use your calculator for that. All right, so this is an inverse equation that we're solving for P. This models the situation. Well, not necessarily, because then what you would have, the equivalent would be C divided by 1.8. And then you have the negative 250 divided by 0.8. What did you get for that? Yeah, and then you'd have to keep it like that. And you'd have to keep this as C over 0.8. And you said you got minus what again? I'm sorry. What, 0.125? You said 3.125. But that would be equivalent and that would be fine. Just don't forget to divide that by the 0.8 as well. Okay? Yep. So either one of those would be perfectly fine. And then it says you are going to write an equation to model, oh, sorry, we already did that. And then it says we have to find the list price of the CD. So we already know what the value of C is. C is the total cost. What was the total charge? Bless you. $13.70. So we're just going to substitute that into the equation. Okay, so $13.70 divided, minus 250 divided by 0.8 is going to give us the cost for P. Okay, so we're going to do $11.20 divided by 0.8. And I don't know what you get. 14, great. Okay, and then just make sure that this is a reasonable price. So the total charge was $13.70, but that includes the $250. Okay, so if it was 20% off with the shipping, that does seem reasonable. then you probably would be paying a different price. I don't know if there are receipts. Yeah. But maybe you found it and he doesn't know what it's for. The poor guy also pays shipping. I hate paying for shipping because it's the same.
Well, that's how they get you. Because it's like, oh, you pay buy $100 versus something, like, we're going to be free shipping.
I know.
And then you end up buying what you pack.
But if you can return it, it's worth it, I say.
And then you have to pay shipping.
Yeah, but a lot of times it's like, oh, free shipping, you spend 50. So I'll just spend 50 and then return what I want. It's a win-win. You just have to, I mean, you're paying for it with your time. You have something to say? No. I'm frugal. Okay, so your 6.2 worksheet. Okay, this is what is due tomorrow, so if you want to write that down, you can.